thank you very much. I'm going to be talking today about GWT RPC, something you've probably heard a lot about in other talks today, the GWT Remote Procedure Call System. I'm going to be covering how it works under the hood and how that impacts how you should use it, and also some best practices for working with it and for server-client communication generally in GWT. And then at the end of the talk, I'm going to be talking a little bit about some future directions that the GWT RPC implementation is going, and also some other kind of related systems that may be of interest. So kind of a little more blue sky at the end. So I just pretty much covered this already. My main claim to GWT fame is that I refactored the server-side RPC implementation in GWT 1.4 to make it more generic and more able to integrate with other pre-existing Java server-side frameworks. So that's kind of the main reason I'm here. I'm an architect at a startup a block away, and that's my website. You can track me down there and harass me with other questions, and I have a links and references page from there. So as I mentioned things throughout the talk, there are links that I'll provide at the end, so no need to worry about tracking these things down yourself. My assumptions in this talk are that most people have a fairly wide range of Java framework experience. I'm going to be talking about integrating with a bunch of different systems. I'll probably ask for show of hands about who's familiar with what I'm talking about. I'm going to skim over the basics, the real kind of hello world examples of GWT RPC. The documentation that's out there in the books are fairly good at covering that already. I want to talk about more advanced issues that don't get as much discussion. And there's one hole in this talk, which is I'm not going to be talking a lot about authentication and login, because those vary widely among all the different possible web apps or pre-existing systems you might be integrating with. So it's take up a lot of time. And just because I'm not talking about it doesn't mean you don't have to do it. It is still very important. If you have questions about specific details of that, do ask, and I will blog about them and kind of fill in that hole after the fact. So what is GWT RPC? Well, if you have a Java server, it's probably the best way for your GWT client to communicate with your Java code. It's sort of the most Java-ish way to do server-client communication over the wire. Looks a lot like regular Java procedure calls, both on the client and the server. It supports complex object graphs, which is a big strength over JSON or other kinds of serialization approaches. So whatever your Java object graph may look like, cycles, different types of object structures, it can pretty much handle that. Anything that the GWT compiler can handle, the RPC mechanism can handle. And it's very highly performing. It's tuned to emit very efficient over-the-wire protocols, and it's tuned to be very high speed at both decoding and encoding. So there's ongoing effort going into that from GWT release to GWT release. One big advantage of using this aspect of GWT is that your code kind of gets faster for free. So that's one other advantage of this framework is the RPC team at the GWT development project is continuing to focus on this. One kind of subtext of this talk is that Joel Spolsky at joelonsoftware.com coined Spolsky's law, which is all non-trivial abstractions to some degree are leaky. A GWT RPC is a very powerful abstraction. You make one line of code and it sloops up a bunch of objects, sends them over the wires, brings them back, or asynchronously calls you back. It's doing a lot for you, but it's doing it in a very specific way. And when the way it does that conflicts with other assumptions that other pieces of your code or other frameworks make, it can cause you enormous problems. And there are a number of problems that people have run into over and over again, so I'll be talking a lot about this. So hopefully the goal of this talk is to give you information to deal with those before they hit you. Biggest difference between RPC in GWT and regular procedure call, even in some cases RMI, or just normal Java calls, is GWT RPC returns instantly. So you make a call, and your code continues right away. The call is going over to the wire, the server is doing things, but your code is not waiting for that. So handling server responses becomes a lot like handling user input. And everyone's familiar with kind of event callbacks and doing DOM programming and JavaScript programming. You write a callback function that handles keystrokes or clicks on buttons or what have you. In GWT RPC, handling responses from the server is almost exactly the same as handling user event-based input. So in normal procedure calls, you would call a Java service that would do some work, and you would immediately, this might take a while, and after a while you get back a result, and you don't continue until you get this result back, and then you can do something with it. GWT RPC, you call the service, you give it a callback object, and you immediately go on with your life. You're not blocking the browser thread, your other JavaScript continues to run. And then sometime later, GWT will call their callback back and give you the result that you were waiting for. So this is a good thing. This is a powerful advantage of GWT RPC over any framework in the browser that tried to wait for the server to come back. AJAX starts with asynchronous, so it's sort of a fundamental part of what makes AJAX AJAX. This is old news to anyone who's done AJAX with raw JavaScript, but if you've mainly come from the Java world, this is a new concept and kind of hard to bend your head around. And many people say, well, is that a must? You know, why can't I wait? I really want to wait. You know, there's nothing in my app can do until the response comes back. Why do I, have to have this callback function? What do I do while I'm waiting? Well, this is not something that you want to try to work around. If your application isn't waiting for the server, then your users aren't waiting for the server either. And the browser is more responsive. You're not blocking the JavaScript thread. The whole web doesn't seem to freeze up for your users. So you want to embrace this. You want to start thinking in these terms and leveraging this. If you try to work around it, the code becomes very horrible. The user experience rapidly degrades. This is not something you want to try to avoid. The fundamental implementation thing that's most important about GWT RPC is that it lives in the compiler. The GWT compiler is a fundamental part of the RPC implementation. If you go to Ray Quammel's talk tomorrow morning about deferred binding and generators, he'll talk more about the implementation mechanisms that the compiler uses for this. But I'm not going to get too deeply into that right now, except to say that the reason it's part of the compiler is that the compiler can do a great job at optimizing what gets sent over the wire. So the compiler looks at what's in your service interface. It looks at the methods that are there. It looks at the object types that are there. It looks at the calls that your code actually makes to your server. And it basically handcrafts the wire protocol and the information that gets sent over the network to be as minimal as possible to cover just what your application is actually doing. So as throughout GWT, the compiler does a lot of optimizations for you. That also applies to remote procedure calls. The flip side of this is that if the GWT compiler can't compile your code or your objects, you can't send them over the wire. So in RMI or Java serialization, you can get some object out of a library or a jar file or something, and you can encode that and transmit it through RMI. GWT RPC, that's not the case. If you can't actually give the Java source to the GWT compiler, then it can't be transmitted to your client. So here's a very brief example of the kind of thing that the RPC compiler does. You have a simple entry class called a blog entry, perhaps, that has a string that is the body of your blog post. That will run through the RPC compiler, and the RPC compiler will generate for you, you never see it, but this is kind of what it looks like under the hood. It will generate a deserializer method that takes a stream reader and a constructed blank instance of an entry object, and it calls setBody on that, reading a string from the reader. So this is basically the handcrafted or automatically crafted code that maps directly to your object structure, and it's very, very inlineable and very optimizable. When you send collections over GWT RPC, since it wants to know what you're sending in order to do the best job possible, you need to tell it what's in your collections. So if you have a list of objects that you know that in your Java code is just a list, let's say you're in Java 1.4, which is all the 1.4 GWT version can handle, so you don't have type information in your Java list declaration. So you've got the need to put in this weird JavaDoc-looking tag that basically tells the GWT compiler what kind of objects are in that collection. If you don't do this, you'll get a runtime serialization policy error, which is very confusing, but that's the way to avoid that in 1.4, and your code will be more optimal as a result. If you want to customize and send particular kinds of objects that the standard GWT serialization doesn't work for, the way you do that is you can define a custom field serializer class that is outside the class that you want to serialize, but in the same package. So you've got some foo object. You want to serialize it in some special way. It's got some custom structure. You know how to do something better than GWT. You create a com my foo underbar custom field serializer class, and the GWT compiler will look for one of those. And if it sees it, it will use it at runtime, and it will actually not just use it, but it will compile that class and inline it into your JavaScript to handle the client-side work that your serializer wants to do. So the methods that you define on your own custom serializer are instantiate, which you may not have to have, but if you have to construct your object in a special way, you can implement the instantiate method that returns a new one of your objects. And then deserialize and serialize, a lot like read object and write object in Java serialization. Takes a stream reader and an instance of the object, pulls all the data out of the stream and puts it into the object, and then vice versa, pulls all the data out of the object, puts it onto the stream. Well, this would be stream writer there. In many cases, you don't have to do this. I haven't had to do it, but it is the mechanism for extending the structure if you have to. So just a quick comparison of GWT serialization versus other frameworks. GWT serialization is fully statically compiled, so it has to look at all the source code, guided by the type args metadata that you supply. You can create your own classes kind of on the side to do serialization of your objects. Native Java serialization is reflection-based, so it doesn't have to have runtime source available to the compiler. And you put read object and write object methods into your classes themselves. So instead of having this separate foo _ custom serializer class, you would put foo, read object, and write object. So you actually modify your own classes to affect the serialization behavior. And Java persistent serialization, if you think of Hibernate or other kinds of object relational tools, EJB3 persistence, those are also serializers, and they also work by reflection and by metadata, and they also create bytecode proxy objects and inject them into your object graph, which is not something that either of the other kinds of things do. It's just sort of to put GWT in context of other approaches. The simplest way to integrate GWT RPC with your server code is to make a remote service servlet class. So you have some interface that defines what you want your client to be able to call. This has all the methods that your client uses to get data, set data, make updates of various kinds, log in, whatever. You define a servlet class that extends remote service servlet, which is a GWT server-side class, a generic one, and it implements your service interface, and you just implement your methods here. And that's basically all you do. You then publish this servlet, your GWT client connects to it, makes the service calls, it calls these methods right here. This is almost certainly the cheapest and simplest way to do it if you're just getting started with GWT. It works nicely out of the box. It was the only way that was supported prior to GWT 1.4. The main downside of it is that your services have to have a servlet with them, which means you've got to write this, you've got to put it in your web.xml. If you're going through some kind of application server, you may not have the ability to put servlets in your web.xml. You may be adding more and more components all the time. You may not want to kind of deal with the servlet plumbing. So this is the reason why I did these refactorings in GWT 1.4, was to enable more generic kinds of integrations. For example, Spring. Who's worked with Spring? Okay, not everybody. So Spring is a pretty widely known component framework. Basically gives you a way to take a bunch of Java code and structure it as components that are related to each other in well-defined ways. So all the kind of glue code of your application can be factored out into this Spring structure, and there's kind of a clarity and consistency to it. There are a couple of different Spring integrations for GWT. There's a server library for exposing pure Java objects. There's a one-page integration, very terse and easy to see what's going on, for exposing annotated Java objects through Spring. So this kind of leverages Spring's generic handler mechanism for web requests to create a GWT RPC Spring handler that can route incoming RPC requests to particular Spring components. Example of what that looks like is you can have implementation. Let's say you've got your server status service. You can write an implementation class that extends this generic Spring class, and you annotate it as an RPC endpoint. And that's all you need to do. You don't have to put anything in web.xml. You don't have to have any specific servlet mapping. Spring will look over all the Java classes loaded and see this by its annotation, and will automatically make it available over the wire. So this is kind of what starts to make your server-side implementation more scalable, is you have to do very little to add new services and extend the ones you've got. Another example is Seam. Who's familiar with Seam? Almost nobody. Okay. Seam is another one of these new frameworks. It's targeted at making Java server faces much simpler, but it's also got a bunch of kind of clear logic for taking your server-side code and structuring it as independent components that declare what other components they use through annotations. So again, the goal is to take your server-side code and break it up into very clear pieces where the dependencies are very easy to see in the code and where you don't have to write a lot of plumbing to hook them all together. So you can, Seam 2.0 has a built-in integration with GWT. It's got a web resource that is the GWT service. You basically tell your GWT client to connect to that URL, and then your RPCs get routed through the Seam structure automatically to the component that you want. I won't talk a lot about the different kinds of components in Seam because I'd have to give a little too much background there, but there is a forthcoming JSR called the WebBeans JSR, and this also relates to the JUICE dependency injection framework from Google. In any case, these are all kind of ideas that are converging, and once this JSR is standardized, this will become a lot more widely known in the community. So I expect there to be a lot of kind of standardization of hooking into these types of frameworks with GWT soon. So in the Seam example, what you do is you give your component an annotated name that is the full name of your GWT interface, and you annotate the methods with web remote, and then that's it. Then all your GWT code can just call directly through to this. There's nothing else you have to do, no XML, no nothing. And you don't even have to subclass any specific class. All you have to do is implement your service interface. So this is a very kind of plain old Java object way to expose your server code. I'm going to skip over this a little bit. Are there any people here who have familiarity with Java server faces? Anyone using it in your projects? OK, well, I'll mention it quickly then. I actually worked on an integration of being able to take GWT components and make them be part of a Java server faces page so that you could essentially do something like this. You could say, here's a component. This looks like a Java server faces tag, but it's actually a GWT little mini application that you can kind of drop into and coexist alongside with all the rest of your Java server faces code. And it can call through to a specific named component on the server side, named the GWT blog component in this example. And you can tweak the contents of this tag to tweak what you're actually communicating with on the server. The only problem is it's broken with Seam 2 at the moment because Seam 2 changed the way they relate to Java server faces, and you don't want to know. But if anyone has a use for this, then please talk to me because I'd love to get some support on fixing it. So that's kind of the basics of, let me do a quick time check. Here we are. OK. If I'm going too fast and if people get severely confused, then just put your hand up and let me know. So I would like to talk a little bit about the best way to use GWT RPC now that you kind of understand some of the basics of how it works. But there's a tension in RPC, which is that messages that you send over the wire, they want to be small because small messages are very quick to process. They're quick to encode and decode. They're relatively efficient CPU-wise over the wire. But the flip side is that messages want to be big because networks are very slow. And the more messages you send, the more variation there could be in how long they take to come back, the more latency you're exposed to. So there's kind of this balancing act between the pressure to make them small and the pressure to make them big. So the best practice here is to only pull the data that is visible to your user at the time. This is something that was talked about in the performance talk just now. If you've got an application that lets your users browse through thousands of things, well, they can never see thousands of things on the screen unless you've got some kind of very, very advanced UI. But typically, you've got 10 or 20 things you can see, and you can page through them or scroll through them. So in that case, you only want your API to fetch the 10 or 20 things they can actually see at the moment. Because I guarantee that if you fetch 1,000 things, it's going to take 100 times longer, and there's no reason to. It buys the user nothing. Not only that, but actually building out that list of 1,000 things, even though 99% of them are invisible, takes a long time to do for GWT in the JavaScript. So just building the user interface takes too long. So you want to tune it to only pull what your user is actually actively working with. That applies to building your interface. It applies to pulling your data from the server. In asynchronous code, you need to rearrange the way your control flow goes. So here's an example of some little blogging demo application I did, where the first thing you do is you call and you get a list of the blog entries, the blog posts that have been made. And then you cycle through each one and you add it to a tree view. So you're making an expandable tree of all the blog posts. This is how you'd write it if it were just a straightforward synchronous app, like a Swing app that was running against a local database, where you'd get the list of entries, and then for each one, you'd get the formatted text for that entry, and you'd stick it into the tree. And you just do that all at once. When you're working with RPC, you have to start injecting callback objects. So the way to kind of preserve the inline flow of the code the most is to use inner classes, where you basically say, OK, I'm going to call this getEntries, and I'm going to pass it a new callback object that simply does what I would have normally done later in the code, except now it's just kind of shifted into this method here. That works pretty well, and it's certainly straightforward to do, kind of refactoring in your IDE. But if you kind of layer this a lot, it can kind of lead to a bunch of braces that make your code sort of all wavy down the middle, and it can be hard to follow what's going on. So you can refactor this a bit more and break out the code that makes that callback into a separate method that has a specific name, has comments. You can kind of see what it's intending to do. So this is sort of a way to use standard Java patterns to make your code more apparent in terms of the control flow as you go through these multiple callbacks. But where this really gets helpful is when you start putting state into these multiple callbacks. So for example, let's say you want to tell the server, OK, I want to tell you to get me all 10 posts at once. So I'm going to fire off 10 separate RPCs, and they can come back in any order. I don't really care. All I know is that whenever one of them comes back, I want to fill out that part of the tree. So in this case, what you would do is you could loop through all 10 entries or whatever, call the service to fetch the text of each individual entry, and for each individual entry, you make a callback object that knows what tree node to put the text into. So whenever this callback comes back, that tree node populates. And the user experience is it kind of looks cool. It's like they're watching it and it goes bloop, and all of the tree nodes fill in for them. And it's also very easy to see what the code is doing, because you can kind of immediately see that when this one comes back for that piece of text, you put it directly into that item. So the goal here is to start thinking of your callback objects as not just these kind of things that are happening at some time out of your control, but actually as pieces of your Java code that you can use all your normal Java patterns to add power and behavior to. All kinds of uses for this. You can have layered RPC, where you have sort of callbacks that immediately invoke other callbacks for logging or debugging, tracing. You can have sequences of callbacks where you have, you make one server call, it comes back, that immediately fires off another one, so you can have kind of a sequence of events gradually filling in an interface. You can have cancelable RPCs, where you could have a timeout associated with that callback object, and if the timeout fires, you set a flag that says, now if this ever comes back, I don't care, throw away the result. I don't want it to update the interface anymore. You can have latched RPCs, so you could fire off, say, 10 requests, and you only need 3 of them to come back before you update your interface. So you keep a counter that's shared among those callback objects, and once they come back, you can go on with your application. And then, of course, you can also, while you're waiting for something to come back, you can set a flag in your user interface that disables various parts of it. The classic, like, OK, you click on the submit button, and it says, processing now, don't click me again. So all of these kinds of things you can do by leveraging your callback objects. Let's see. This is the halfway point. That's about right. This is what I've talked about so far is mostly about pulling data from the server. There's also a lot you need to think about in terms of pushing data back up, because the whole goal of your GWT application is to enable the user to do something. And so once they've done it, you need to tell the server what it is and make sure that the server confirms that it was done and informs your app what happened. So sometimes, if you're writing a kind of very granular API where like each little call sets one thing and then another call to set another thing, which is kind of the way you would write a normal Java API, then you might find yourself, like say you're building an online booking application, or like a seat reservation application would be the classic one, where they've got to pick their seat, they've got to pick, smoking, non-smoking, what type of meal they want, all of these bits of information. If you have separate calls to set each of those, then you might wind up writing RPC code that makes 5 or 10 calls to tell the server what it was that they want to reserve. The thing that you want to do is, to the extent possible, you probably don't want to tell the server all the little things that you know about what the user is doing until the user is actually ready to reserve. There's one, there are intermediate cases to this where you might have the user pick 2 seats that they want to be next to each other. You give them a list of all the available seats. They pick 2 that are next to each other. You make a call to the server to say, hold on to those 2 seats for the next 15 minutes while the user is thinking. And then you get all the rest of the information from the user until they actually hit, buy this. So, but in general, the less things your server has to keep track of and the more things you keep in your client, the better. But you also want reasonably small messages once you actually are done and once the user is ready to buy. So again, there's this balancing act. So you can, again, this kind of sequence of things that happen together, one alternative you have is to send to the server a whole list of things that you want the server to do. So you can actually have a sequence of actions or a kind of command pattern where you send over a bunch of objects that tell the server, first book this 2 seats, then set this meal, then do this, then do that. So you can kind of keep your nice granular API structure on the server, but you can have it happen in one RPC call. So this is, again, using classic kind of Java patterns to leverage the ability to kind of pass full Java graphs back and forth in GWT RPC. The downside of this is that you can't trust the client. And so this is actually something that I added after seeing Billy's excellent security talk earlier this afternoon. And many of you may have seen this. The client can do whatever they want. They can hack through the GWT JavaScript. They can de-obfuscate it. They can synthesize calls to your API. Just because your code bundles together these 5 calls in this particular order and is nice doesn't mean that any random client couldn't do any arbitrary sequence of API calls. So you have to watch out for this. You need to make your API authentication aware. This is why, even though I'm not giving the details on it, you still have to make sure that there is some login and authentication entry point to your API, which is broadly not that different from any kind of login framework because all API calls are just HTTP calls, so all your normal session authentication code can still work. And you want to keep your user's login information and authorization information in the web session. So all your API calls can say, OK, this guy is Joe Smo customer. I shouldn't let him create a new user. I should only let him make normal domestic plain reservations. And you also, whoa. Oh, I hit my mouse wheel. You also want to make sure that you keep all the authority on the server. So you don't ever want the client to be sending over things like, OK, here's how much this thing should cost. Here's how much the user should pay for this item they're buying. The server should be the thing that knows how much that item costs. All the client should say is, I want to buy item X. You want to check the contents of your API's calls that you get from the client relative to what the user is allowed to do. You want to make sure that API calls happen in the right order. So if your application is enforcing reserve the seats before you book them, then make sure it doesn't break if your hostile client calls booking before reserving. And you also want to separate your conversation state from your commit state. So all the kind of things that the user is filling out as they go, you want to make sure that most of that stays on the client so that you're not continually talking to the server about it, because continually talking to the server about what the client is doing makes more state on the server, makes it harder to scale, and increases the API surface area for attack. So you want to kind of keep it very focused on what the server actually needs to know once the user hits the big button. The next section is kind of the biggest rat hole that people run into when they're coming from kind of a Java Hibernate world and they start using GWT RPC. So GWT makes it easy to call your Java backend, right? Many Java backends use Hibernate, JPA, Java Persistence Architecture, EJB3, serialization, all kind of the same thing, top link. The GWT abstraction is to take this whole graph of objects that you're sending to the client and bundle them all up into an encoded string and send them off. It needs to see all the source of those objects. The Java persistence abstraction is to load a partial graph from the database. So it's pulling individual objects, and it's pulling a couple of objects related to them, and then at the fringes of what it's pulling, it makes these magic proxy objects and lazy collections and things that you're not supposed to know about because the abstraction is handling them for you. But conceptually, it looks to you like a full graph, but really it's only the pieces of the graph that you've bothered to touch so far. So there's menace lurking here. You put these two things together and wham, you get total conflict. The abstractions lock horns, and in practice, GWT loses badly every time because it will try to serialize this lazy proxy object or this CGlib thing that it's never seen the source for. It has no idea what Hibernate is or what it's doing. And bam, your application blows up on the server. So there are a number of ways to deal with this. One of them is to use what are called data transfer objects. People who have been programming Java for a long time get flashbacks when you start mentioning data transfer objects because it was originally intended to separate your persistence code from your JSP pages. Because your JSP pages in early persistence frameworks, they couldn't render anything from your database because it would blow up when they tried to make calls on those objects. So you had to send separate objects to your JSP pages. Well, now it's kind of more really about data transfer objects because you're actually transferring something all the way over the network. So you can take your persistent objects and copy them into a separate structure of data transfer objects. It's kind of a duplication, but it also gives you a lot of control over what actually goes over the wire to your client. And you can limit the features that are used in your data transfer objects. Like right now, if you've got entity beans that use a bunch of Java 5 annotations, you can't give those to the GWT compiler, so you almost have to copy them into some Java 1.4 friendly objects that GWT compiler can handle. But then there's a risk of, like, this is a huge pain, right? Anytime you've got a duplicate set of objects, you've got a bunch of manual code to write, so nobody likes that. So you can generate these data transfer objects. You can put them as kind of part of the build step of your project. There's a Java Codehouse Jam project that lets you walk over a set of classes and render output from it. The API is fairly nice. You can compile these data transfer objects into a standalone piece of GWT code that all of your applications can use, so they're all consistent in that way. Kind of structure your build process nicely. The API for doing that, this is kind of sample Jam code where you're walking over the fields of an object. You can skip over field types that the GWT client side can't handle yet, so you can kind of prune things out. You can also use server-side reflection code to fill that object graph out. There's a pre-existing project called Hibernate for GWT that does a lot of this already. So if you have this problem, definitely take a look at that. Another approach is to customize the way RPC works in GWT. Now, I mentioned this custom field serializer already, but the problem is that that doesn't work for this case because the problem isn't with your nice friendly classes. The problem is with these magic secret Hibernate things that you are supposed not to worry about. So you need to customize the way the GWT compiler or the way the server-side RPC walks over your whole graph and what it does when it gets to the edges. So you can override the server serialization stream writer class, which is the class on the server that takes an object graph and puts it over the wire. You can make special handling of persistent classes. You can write code that looks something like this, where you're walking along your object graph and you come to an object of some type, and if it is a persistent set, some magic Hibernate thing, then if it's been fully loaded, you put its data on the wire. If it hasn't been fully loaded, you put null. So you're kind of pruning off what you send as it's going out. And this means that you don't have to write any custom data transfer object code, but it does mean that you are slightly more exposed to changes in the RPC implementation. Now, John, let's see, this fellow I spoke to before, is he here? Yes. You've got an interesting approach where there's kind of some places in the RPC code now where if you just were able to override one method, you could do this very cheaply. And that's kind of the refactoring that I did with 1.4, where the code was all there, but all that needed to happen was GWT needed to let you tweak it a little bit. So these are the kinds of changes that the GWT team is very open to making. And I'm going to push for a change like that in 1.5 so that we do get more flexibility of the serialization to handle cases like this. I think they'll be very receptive to it, especially if we come up with a patch ourselves. So this is one place where I really want people to know that the GWT team it's an open source project, and they are very interested in what people need, what people are blocked on, and especially if you can come up with a patch that you think would solve it, they're extremely interested in reviewing that kind of thing. So the final part about persistence, I'm almost done with this subthread, is once you send your objects back up, you've got to put them back into the database. And the question is, well, what if the database has changed in the meantime? Or what exactly did your user do with this big pile of objects you're sending back up? What is your server going to do with that information? I'll skip over this a little bit, but there are some people who say that this is a bad thing about GWT, that you have to track what your user did and send over the changes yourself. If you have all your state on the server, then Hibernate can track what your user does as they're using your web application and push it to the database for you. I think it's actually an advantage, because if you've done a lot of work with Hibernate, you know that if you hit any JDBC exception, you hit a unique key violation, you hit a stale object, you hit any kind of ID problem, Hibernate throws up its hands and says, I don't know what to do anymore. You have to throw away all your objects, and you have to basically start over, reload, and reapply all your changes. And every time I hit this in Hibernate code, it's incredibly frustrating, because suddenly all the things that Hibernate said it was doing for me are kind of out the window. So when you're doing your GWT APIs, you need to structure them to make it clear what the changes are that the user is making, so that your API can tell the server, here are the changes that the user did, and the server can intelligently apply those to whatever persistent state there is. If there's any problem with that, if someone else booked those seats at the same time, or someone else, there was some kind of database commit problem or whatever, you can provide better exception information to your client. It kind of raises the level of the conversation. Instead of worrying about, okay, Hibernate, figure out these bits and put them in the database for me, and if something happens, well, who knows what the problem was. You're kind of hoisting the conversation to, here's the changes that were made. If there's a problem, here's what I want to do. So it makes for clearer error handling, and it probably scales somewhat better too. So this kind of gets to a wider point about API design with GWT RPC. If you've got a bunch of kind of create, update, database APIs, you've got your whole JDBC API, what have you, it's kind of tempting to just make an interface around that and have your GWT code use it. It works. You can do that. But the difficulty is that as your API grows, and as the number of data objects you're sending grow, and the kind of scale of changes the user can make grows, your API becomes underspecified, because it's hard to know exactly it's kind of all the information then lives in the objects you're sending back and forth, rather than living in the operations that your API explicitly defines. So that can lead to kind of this big pile of spaghetti objects, and you're not exactly sure what to do once they hit the server. So this is the reason to go for making your APIs very intentional, where the methods that you're implementing should kind of be clear in terms of what you expect those methods to do. Not just, here are the objects that I work with, but here's the booking that's being made, or here is the reservation that has to be safety checked against all other reservations. The other issue is that the general database objects you have may or may not be what you want your client to deal with. They might have a lot of kind of hairy detail in them that's not relevant. So this is actually kind of a good reason for the data transfer object pattern, is your client code can be a lot simpler if the objects that you're sending to your client are more meaningful in terms of what your application is actually doing. So you probably want to think more about services on your server rather than just data accesses. Service-oriented backends may scale better. If you keep secure state only on the server, then it works around a lot of security problems. I've kind of already mentioned that final point. One other thing that a lot of people trip over when working with GWT RPC is, what does serializable mean? Right? In Java, people are kind of familiar with the concept of serializable. You make something serializable, you put the interface on it, you can send it through RMI, you can send it to various kind of persistence frameworks. The GWT serialization is almost completely different from Java serialization in every way. Originally, GWT had an is serializable interface. And this confused the hell out of people because now there's serializable and is serializable. And well, something that is serializable is also serializable, and what's the point here? And but the general reason for the distinction is that Java serialization is hard-coded to a particular stream protocol. There's read object and write object methods. And if GWT tried to use those kind of as is, it wouldn't work well at all. The format is not efficient for JavaScript. It's a completely different type of structure. So what they wound up doing in the 1.4 release is to say that rather than having to put this is serializable interface on everything you want to send, which was kind of a pain, especially for most objects that are pretty simple, GWT has no problem. Now, Java lang serializable to GWT just means it's okay to send this. So the assumption is if something is serializable, the GWT compiler will try to use its normal encoding to put it on the wire. It does not mean it will use your existing read object or write object implementations, because it won't. Those have no meaning to GWT RPC. If you want to do that, you write a separate class, like I said before. And it's basically a convenience for allowing you to take all your existing serializable stuff and put it on the wire without having to mung it up with a bunch of GWT interfaces. Yes?
Absolutely no difference between is serializable and serializable. Like, is there any reason to not use is serializable anymore?
The question is there any point to is serializable anymore? That's kind of a good question. I would say it's arguably clearer if you aren't using Java serialization. If you don't have any kind of Java serialization, serial UIDs or read object, write object methods, if it's only going over GWT, then just use is serializable. But in general, yes, probably there's not nearly as much point to it as there was before the 1.4 release. So now we're getting into the home stretch. Let's see how we're doing. Okay. I'd like to talk just a little bit about some cool tricks that people are doing with GWT RPC, talk about the changes coming in the next release, talk about some future possibilities and extensions that have come up on the forum, get some feedback on that, talk very briefly about some other things that are interesting if you think about RPC-type frameworks, and then wrap up and leave some time for questions. So one use case that people have is when you're working on like an iPhone application in GWT. You want to send over a bunch of data to help that application set itself up, but you want that to happen as fast as possible, and you want to only do it in one round trip to the server. So something that people have done is they've pre-serialized the data on the server. You load all this configuration data, you bake it down to a bunch of string, and then when someone logs in, you just blast the same string out to everybody. It's instantaneous. You can even cache it in your edge cache. And then on the client side, you can take that string and run it through the client-side deserializer, and you get all your objects out. So GWT 1.5 is actually going to make it easy to get a reader that you can use to do this. So you don't have to make a server call and get a response back. You can just do an HTTP GET, take what you get back, feed it through the deserializer, and you've got all your objects. So this is very useful for kind of speed optimizing startup. GWT 1.5, the biggest thing they're working on is Java 5 support, finally. So now you can pass Java 5 code to the GWT compiler and it will work. They're working on, right now they're bogged down in enumerated types. How many people here knew that Java 5 enumerated types have mutable state? Basically means you can have an enumeration object that has state in it that you can change, which is insane to everyone who has ever talked about or thought about this. But it is true, and the GWT compiler is currently probably going to taking 2 weeks just to cope with that. But at the end of it, it will support enumerated types. It will support generic collections. GWT type args will go away. You just declare a list bracket, foo bracket, and the compiler will know how to put that on the wire efficiently. The other great thing will be support for annotations. It's not yet clear what GWT itself will be doing with annotations. There are scads of possibilities, but right now they just want to get them to work. And they'd like to make it so that annotations that you don't have source for, like entity bean annotations or other kinds of component annotations, whatever, you can still pass them to the GWT compiler and it will just ignore them, as it should. So that's another significant goal of 1.5 that I think they've mostly got working now. One issue with the current serialization is that it's recursive. So you pass over a deeply, deeply nested tree of objects, And it will loop through that and recursively call deserialize on each node all the way down. And since many browsers have a JavaScript stack that is only like 30 levels deep, or even less in some cases, you can, if you have like a 50-level deep tree, it will blow up in deserializing. So there's discussion of transforming that to be an iterative algorithm, so it actually just loops around digging through your whole tree without consuming JavaScript stack. They may even work on making it deferrable, because if you send back too big a pile of objects right now, you can get a slow script warning. Deserialization is fast, but it's not instantaneous. So if you run into that right now, your only option is to send back less. Doctor, it hurts when I do this. Well, don't do that. But the goal ultimately would be to make it so that the deserialization can stop and wait and then pick up a little bit later. They think they can probably preserve the current custom serialization code. It's being discussed on the forum right now. One other thing is there's cases where you send over metadata in your requests and responses. So you use your HTTP headers for authorization tokens or for conversation information you're kind of carrying, or Spring Webflow where you're doing a bunch of interactions and you want the server to know that these are all related and there's some state related to this series of calls you're making. And those typically use the HTTP headers because you don't want all that stuff in all your API methods. It's kind of out-of-band metadata. So they're working on a design to allow this. It's not yet clear what the API will be. It's possible that there'll be a different extension of the async callback so that you can add a couple of arguments to your async callback object and it will get the request and response objects and you can do whatever you want with them. But again, this is being discussed on the forum right now. If this is useful to you, then chip in there. Another possibility is JSON-style encoding. Right now, the code that I showed you, the generated deserializer code, basically a whole bunch of nested function calls. Now, the GWT compiler will inline the hell out of that, and it will be as fast as it can be in JavaScript, but it's still not as fast as the browser itself parsing JavaScript, object notation. So JSON itself is not usable out of the box because GWT needs to pass complex object graphs and so forth. But there is a possibility that you could change the way the RPC implementation encodes things such that it would be mostly JSON with just a little bit of kind of untangling code in JavaScript, which could potentially speed things up a lot. However, there are a bunch of kind of technical issues to work out with this. The last time this was discussed was back in June. It's been on hold since then. But this is something that will come up again once they get 1.5 out. And this is an example of the kind of reason why GWT RPC is good to use, because once they get this working, all your apps just magically get suddenly faster, especially with big payloads. Another possibility that is being discussed, a lot of people have a use for it, is right now, all of your RPC is call this method, get these objects back. Call this method, get these objects back. There are a number of frameworks that kind of support declarative data binding, where instead of being very kind of back and forth Java code, instead you say, I want a tree, and I want the tree to render this file directory. I've got some file directory object on the server, and I want my tree to show its contents. And that's all I want to do. I don't want to deal with incrementally loading things as the user expands the tree. I don't want to deal with pagination. I want the framework to handle all of the back and forth data loading involved with that user interface. This is not something that GWT does at all now, but right now there is work on a declarative user interface layer for GWT, so you can write XML that basically describes your tree of widgets in your GWT app, and that will get generated into JavaScript, and so you can kind of use more of a page design metaphor for building your GWT app. Once you have that, data binding and integrating with RPC becomes kind of a natural extension to think about. So there's a 9 a.m. breakfast session on Thursday with me and Joel Weber. He's going to talk about the declarative UI work he's already done, and anyone who's interested in this problem area, please come to that. This is kind of, the goal would be to make pagination be something you don't have to do. It's kind of a standard part of the framework in some sense. There are a lot of data binding efforts to do generic frameworks like this in the community right now. There's also JSR 295, the bean binding JSR, may be interesting to people who kind of want standard support for this. I think I'm going to skip over some of this discussion of generalized mapping. So I'll just kind of say that wild-eyed speculation that right now loading things from the database into your Java server and loading things from your Java server to the client are very similar mapping problems. And it's annoying that you have to handle them completely differently. If there were kind of a unified framework where you could say, here's what I want from the server, here's what I want to be lazy, and then here's what I want to send to the client, here's what I want to ignore, here's what I want to filter, all as kind of one set of metadata that the framework just handled all the way from the database to your GWT client, that would be pretty cool. So there is some work being done on this at Microsoft Research. It's kind of the goal of attacking the data transfer object problem at the framework level rather than being something everyone has to do separately by hand. This is something that GWT has kind of been agnostic on in the past, but I do think it's a natural direction for things to go. So if this is a problem that you struggle with, then let's get on the forum and start talking about a potential overall solution to it. And just wrapping up my last couple slides, I wanted to mention about RMI relative to GWT. Right now, it can kind of be suboptimal. There's been a lot of work on optimizing RMI because the basic reflection implementation can be very slow in some cases. And this is sort of not directly pertinent to GWT, which is straight client-server, but there have been systems like Genie that try to use RMI to communicate between a whole set of machines. Like, I talk to this machine, which hooks me up to that machine, which is connected to that machine. And it's been proven that the RMI class loader structure is fundamentally broken for that. You get so confused about what classes you're getting from where, and you get class not found exceptions because the class loaders are different. And so basically, RMI is not capable of doing that. There is a new system coming out from Google called Kaja, which is enabled. The intent is to make it so that you can download JavaScript that kind of, so like one person could write a JavaScript program that they upload to some site, and you could download that JavaScript program, and you could know that it was not going to hijack anything, it was not going to steal any data and upload it, it was not going to change any prototype objects, it was not capable of doing any of the stuff that was talked about in Billy's security discussion. It's basically a sandbox for JavaScript that works very fine-grained and has relatively high performance, and it enables you to actually have code that you can safely move around on the network and load and run on any user's browser. It's going to be very interesting to look at using GWT to write this kind of code. So the kinds of things that RMI can't do right now, of like fully letting you move from server to server and communicate here and there, this is a potential way to do it in current browsers. There's no changes to JavaScript needed to do this. So this is also an interesting thing to think about. And the last one is this Link 2.0, language integrated query. This is a big contrast to GWT, but Visual Basic.net lets you write inline SQL and inline XML in your Visual Basic code. And it will automatically translate that into SQL database queries. And they're actually working on extending that to where you can write a Visual Basic program that's written as though it were just running in the browser. And it will compile that and pull out all the server parts of that code and handle all the RPC and make it all asynchronous for you, which is a completely brain-twisting possibility. And it may go completely haywire, and nothing may ever come of it. But it's nonetheless something to kind of keep an eye on, because they also are working on compiling Microsoft Intermediate Language, the thing that Visual Basic.net and C# compile into. They're working on making that run in JavaScript, kind of Microsoft's answer to GWT. So this is an interesting area to keep an eye on the competition. So that's the end of my talk. I want to thank everybody for coming. I want to really thank the GWT team and Pearson. That's the URL, so write that down or hit it for links to pretty much all the stuff I talked about. And I just want to invite everybody to boldly go forth and build brilliant applications. Yeah, the URL is robjsoftware.org/GWT2007.
So we have time for 1 or 2 questions, if anyone has a question for Rob.
Did I stun everybody?
You sure?
Or is it the end of the day?
There you go.
My question relates to pagination of data. Do you have any tips or best practices for implementing that on the server side?
Most people who do it with a fairly standard, API start count. There's not, I'm not sure. That would basically be the way it looks in your APIs. Instead of just passing back a generic list, you tell it exactly how much you want and exactly where to start in the list. Was there a question more specific than that? Okay.
Hi, do you have anything coming up in RPC, like what Ruby on Rails is doing, like giving you database structure, in your HTML form, like you just simply dump your form into, database straight away, rather than, right now what you do with RPC is like create the HTML form and then pass that and have some backend stuff, doing that for you,
Right, right.
It's a simple
Yeah.
thing, but, it's
Form-based
it helps a lot.
applications are kind of a pain to do with RPC right now. Because as you say, you've got a bunch of kind of manual code to pull all the data out of all the form elements and pass it over. That's very much what this declarative data binding concept is about. So instead of having to assemble that and do it all yourself, you could instead lay out your form in XML and say, here are all the pieces of the form that correspond to this form bean, and as they get updated, here are the, I want to define the validation once on the server, have my GWT client respect that, and have it be enforced again on the server once I send it over. All those kind of problems are what I meant by the declarative data binding problem space. So if that's interesting to you, definitely come to the Thursday 9 a.m. breakfast. There's not a lot of framework support for that in GWT right now, but there are a bunch of kind of community efforts to build things like that, and I think that fairly rapidly over the next year or two we'll see some widely adopted solutions.